So I want to demo for you the memory overcommit feature of AOS 6.0 and later. Basically what memory overcommit does is it's a feature that allows you to achieve virtualized optimization of the host memory. So if you have, for example, in my instance where I have 384 gigs in each host, I want to make sure that I maximum utilize that across my VMs. Even though I may go in and configure a VM with 128 gigs of memory, if that VM is not utilizing all 128 gigabytes of memory, I want to be able to take that unutilized memory and use it for other VMs. And so that's basically what memory overcommit allows. It allows the host to monitor the VMs, detect when memory is underutilized, and when another VM needs memory, allows you to utilize that memory for that other VM. So let's show you how that works. Okay, so we're going to give you a little bit of a tour here of what we've got going on. This is a little bit of an older cluster, so it's a G5 model, but that doesn't matter. Everything is still in play. It is currently running AOS 6.1 and the latest AHV release. We have 4 hosts in this cluster, and if you look at the actual hosts themselves, each one of the hosts has approximately 384 gigabytes of memory. So that is the configuration that we have going on right here. And then, so as you can see, I've got 8 servers here that I have configured with 128 gigs of RAM. That's quite a bit for a VM, but I wanted to go ahead and set it to that because each of the hosts has 384 gigs. I wanted to set it to 128 on each of the servers because I'm going to commit all of that memory to being in use because I want you to see what the overcommit, what the effect on memory overcommit is when those servers are all being utilized. So in order to enable memory overcommit, we have to log into the CLI of one of the CVMs, and we have to actually run a command to enable memory overcommit. So it's an ACLI command, and it is a VM-specific command, so we're going to update specific VMs. In this case, we're going to take server 1, oops, it's capital S, server 1, and set memory overcommit to true. Oops. There we go. So you can see it's as simple as that. So I'm just going to go right down the line. And do it for all the servers. Now, the VMs do have to be off whenever you issue this command. So if you have the VM startup, you need to shut them down in order to commit that. Now, if you want to verify that the overcommit is in place, we can just do a vm.get and type in the server name. And what you'll see, if you look at your list here, you'll see that memory overcommit is set to true. All right, and then we're going to go ahead and start all these VMs. So now that we have all these VMs started, you can see that even though I have 128 gigs of memory committed to each one of these VMs, if I go and look at my cluster, you'll see that the cluster is only about 57% used. So if I go back over to my VMs, and with a terabyte and a half of memory, that's definitely these 8 VMs is going to come out to be just a little over a terabyte of memory. So if I want to go ahead and clone these, I could clone 3 of them. And we'll start that at prefix server. Prefix starts at 9. We're going to give it 128 gigs of memory. Okay, so there's server 9, 10, and 11. I'm going to go ahead and fire those up. Now, keep in mind that these VMs do not have the overcommit turned on for them yet. So it's going to go ahead and allocate the full 384 gigs of memory to those particular VMs, which is going to put us pretty close to our 1.5 terabyte that we have allocated in the cluster. So you can see we go up to about 63%. All right, I'm going to go ahead and enable overcommit to those guys. So I need to shut them down. So we're going to power off. So in order to, let's go ahead and enable that on server 9, 10, and 11. And then we'll go ahead and fire those guys up. So if you're keeping score, you'll know that running those 8 VMs, we're at 1.4 terabytes of memory approximately. And if I attempted in a cluster that I've only got 1.5 terabytes, if I attempted to clone 2 more VMs, it wouldn't allow me to do so because we wouldn't have enough physical memory. Prior to AOS 6.0, it wouldn't allow me to clone or create 2 more VMs because you wouldn't have enough physical memory to support it. But what's going to happen, since we've got oversubscription turned on to all these VMs that we have here, what will happen is that it will see that there is unutilized memory in some of these VMs, and it will allocate it so that we can spin up new ones. So I'm just going to clone. I'm going to call this, let's start with server 21. I like that name. Let's do two, and then we'll go starting at index 1. So it should be server 21 and 22, each of those with 128 gigs of memory. So we'll go ahead and save that. And we've got server 21 and 22. They're created. And then we are going to go ahead and power those both on. And so there you have it. You've got 2 more VMs that I've just created. If you do the math across the board here, I've got a total of 11, 12, 13 VMs that are all running at 128 gigs of memory, which comes out to be about 1.6 terabytes of memory each, or 1.6 terabytes total. And as you can see, if I go back over to my home page, we're sitting at some high memory utilization, but you can see that what's happening here is that it's still allowing those VMs to start up and be used. Now that is taking into consideration that there is underutilized VMs here on the cluster. And so therefore those VMs are being able to utilize the unutilized portions of the memory in order to spin up those 2 new VMs. So that's what happens when you have unutilized memory on the cluster. So I'm going to go ahead and delete those 2 VMs because we're going to redo this little test. But this time we're going to put these VMs at a maximum utilization. So basically what we're going to do is I'm going to go ahead and connect to this first one, show you what I'm doing here. So what I'm going to do is I'm going to use a tool from Microsoft Sysinternals called Test Limit, and I am going to, in essence, commit the memory or allocate the memory using a memory leak function. And that's over in test. And then we're going to take this command, and I'm going to do it as a leak and touch, and I'm going to do 100. I want almost all the memory to be used. And so you'll see it jump up. I think it'll actually stop a little bit short of 100. A little over. Okay, so that's perfect. And so I'm going to spin this up on all the VMs so that you can see actually what's happening over here. And if we look at server 1, if I refresh the page just to get the most current data, if I look at server 1, you'll see its memory usage going up already. And it shows it currently at 12.97%, but there's a little bit of a lag in the information, so that'll continue to rise. All right, so I'm going to pause here, and then I'm going to spin this up on all those other VMs. So as you can see, we've got all the VMs spun up, utilizing most of their memory. So they're all sitting anywhere from about 75 to about 80%, with a couple of them above 80%, depending on how far into the memory spin up they are. But the idea is that we're using pretty much all of these VMs memory, so there's not a whole lot of spare memory to be used. So if I tried to clone, let's just say I tried to clone 5 VMs, all utilizing that 128 gigs of memory. And we're going to start it off with server 3, so that they'll show up at the top there. And we're going to go ahead and click Save to spin those up. And then we're going to watch our tasks to see those VMs being created. So the clone actually succeeded. And if we flip back over, you'll see that we have those VMs created. And let's see what happens when we try to power those all on. And we'll just go ahead and filter for those servers so I can see them all. And watch them as it utilizes the memory that's available. And if we look at our tasks, we'll see that we've got server 31. It's already running. And it's attempting to fire up. Oh, we've got another one that fired up, server 32. And as you can see, we're utilizing just about all the memory in the cluster right now. And as you can see, we ran out of memory, so therefore it couldn't start up that last VM, simply because of all the memory that's already in use. So as you can see, the solution is really dependent upon there being unutilized memory in the existing VMs that are running that have that memory overcommit feature turned on and enabled. But once you run out of unutilized memory, then you'll see that you may have an issue with VM starting. So that shows you how memory overcommit works from a high level.